The ABC telegraph was a Victorian invention that let people send and receive telegrams using a machine like a typewriter. This is the first video showing the inside of the machine and how to take it apart and, if you're lucky, get it back together. It's the machine used by Andrew to chat up his sweetheart Mifanwi in Emancipation, a fictional romance set in the 1860s. I'll put a link to the book in the comments below. In the 1970s, I helped to redesign the airline's telegraph network, replacing electromechanical teleprinters by screen-based interactive terminals that could reserve airline seats in real time. Telegraphs feature in my non-fiction books about Victorian history too. There's a video in this series about one of the Morse code machines that was used in the Crimean War in 1855 after a line was installed under the Black Sea from Romania to Sebastopol. Let's look into the ABC machine. It obviously needed a new glass. When you take off the glass and the dial, you find a brass assembly holding the buttons, which I've taken off and you see here upside down. That's when you start wondering how you could possibly get it back together, with 30 dangly spring clips that obviously connected each button to something down below. The buttons are filthy after a century of use. With the button assembly off, the steel dome underneath is equally filthy. Down below are two rotary arms linked together by a friction clutch, which is that big spiral spring. There are 30 slots to hold the toes of the buttons, each one with a dimple, which is obviously meant to hold the end of one of those spring clips. You start to see the general idea, but first impression is it can't possibly work. That's because you don't know how precisely the Victorians were able to engineer mechanical devices. Here's one precisely engineered feature: a tiny roller-linked chain held under adjustable tension that runs around inside the brass disc with the slots in it. Pressing one of the 30 buttons displaces the chain inwards and causes the previously pressed button to be pushed back to its upright position. Only one button can be down at any one time because of the chain. We'll see that in action later. Here's how the friction clutch works. As you crank the dynamo, it turns a toothed wheel which drags the short arm around, looking for a button whose leg is outstretched. The longer arm will meanwhile transmit pulses from the dynamo. When the short arm hits a button leg, it unhooks itself from the toothed wheel and stops. The clutch disengages and the electrical pulses stop. Having cleaned up the keys, here's how I got it back together. I cut a circular shape out of foam board using a diode laser and light burn software, using the two cuts shown here. With this, I could balance all 30 buttons, now clean and shiny, with their toes in their slots and outside the chain. The Victorians didn't have diode lasers, but they must have made a similar jig to assemble this thing. There are 3 brass components to be installed now. The first is a slotted ring to clamp the buttons in place, seen installed here. The second is a slightly smaller ring that you can see bottom left. It overlaps the knees of the buttons and stops them tilting when I'm fixing the dangly spring clips down below. I have to do that through the remaining circular aperture before installing the third component, which is the Y-shaped piece shown in this image. Now the most satisfying bit. Through the aperture, those 30 wandering spring clips can be nudged into their dimples one by one. You can see how they provide a detent for each button as it is impressed and tensions the chain, so that the button previously pressed is flipped back by its clip. The oscilloscope shows the pulses generated when the pointer moves through 15 spaces on the dial. Each space moved creates one pulse, alternately positive and negative. Pulses are more than 80 volts, that being the maximum the scope will show. I don't have the receiver that belongs with this transmitter, so I tried to decode this signal with an Arduino microcontroller and a bidirectional optocoupler circuit. I haven't succeeded yet. Meanwhile, I'm glad to show you a clean and working example of this Victorian invention.